No way.
Dennis is too generous, in my opinion.
It's nice.
Yeah, too nice. Yeah. Anyways, don't worry. I'm not this way in maths or physics, so you don't have to worry about being too nice. I had a look at your coursework from Roland. Did you get your results back from it? No. So I can give you that on Friday as well with your physics.
Like
You packed Friday, like.
like Friday,
Everything.
Before 1 or after 1.
In our class. When's our class on Friday?
Do you want to play?
Do you want to play?
It won't change the result, I'm sorry. It's going to be marked the way it is. I have to give you the physics exam results on Friday, and your maths coursework 1 and your physics coursework 1.
From 3 o'clock to 5.
That's the time then, after prayers.
Yeah, good. So it will change then. Maybe.
We'll see.
So it means
Maybe at around about 2 o'clock I might feel, something's telling me I should relook at the papers.
Or from when you bring the papers, they will fall down in your seat. Oh, I should give one more.
Never know. But anyway, it's Fridays when you get the results. So I was talking to Roland about your coursework. So yeah, it was okay. Mostly B's and C's for your maths coursework 1. I don't remember who got what, but I did see 60s and 50s. So
No
B's
A,
and C's.
no B.
Now there could have been an A, because I was only quickly looking through them. I did notice that yours was 2 days late.
Oh, my one was also one day late.
2 days late. Yeah.
Mine was.
No, it is 2 days late,
10
because
minutes late.
Ronan gave you the penalty for 2 days late, which obviously brought your grade down to the next grade before. You know what I mean? What you gonna do? Anyways, you'll find out Friday, okay? So what we'll start with the physics is we'll have a look at the exam. So before I start, what is your feedback on the exam? Good, bad?
Then was
So
it was not it was not too difficult, but we should have.
Wasn't that unexpected, was it?
It was.
How so?
Like, I didn't expect to, like, the formula of it, everything, the questions.
But I kept the questions nice and straightforward, I thought.
They weren't, like, okay, so we focused too much on things that we thought that
Thought
would have
that
been
would
there,
come,
and
yeah.
it would have been too hard. And the things that we took for granted were mostly the things that were actually in it.
And what have you learned? What is the lesson you've learned? Don't take anything for granted. Yeah. Right, let's have a look. Physics intake 1, end semester 1. So we'll go through the questions now. I think section A was kind of okay, but people really kind of fell down on section B, which kind of confused me. But anyways, we'll go through the questions. So we had to answer all of the section A questions. So the first one is, what's the length of a pendulum that has periodic time 2? So we'll do this one together. So A1, yeah, if you want to write this down. Why has my pen permanently changed now into this weird marker mode? A1. Right, so the T is 2, yeah, and what's the formula for the T for a pendulum? Yeah, T is 2 pi root L over G, so 2 equals 2 pi root L over G, so 1 equals pi root L over G. What should I do next? Square, or move the pi, doesn't matter. Will I move the pi? 1 over pi equals root L over G. Okay, what's next?
Remove the root
1 over pi squared.
Square everything, yeah. 1 squared over pi squared equals L over G. So my answer is L equals G over pi squared, which equals, what's that, 9.81 over 3.1415 squared, which is like really nearly 1, is it? Where did I put my calculator? Uh, 0.994. Yeah, what was so hard about that? Anything? No problems with this? Any questions? No? All good for this one? Okay. Can I go to the next one? Number 2. This one here. This one here, I don't know if maybe one person or 2 people. This one was answered really badly. Really badly. And people who did it some people who did it a very odd way. Not that it was wrong. Somebody here got the time to go from the ground to the maximum height. Was that you? And then the maximum height to the ground. Yes. Not the quickest way to do it. Did anyone else do that?
But you did it this way.
No.
Yeah.
No. The only reason I would have done it that way is if the question asked for the time to the maximum height. But here they don't. They just want the total time. So the girl throws it up from a meter at 29 meters per second. So what happens is she's here. The ball is 1 meter off the ground and she throws it up and it comes back down. And the speed she throws it up at is 29 meters per second. So this is just a UVATS problem, of course, which you all realise that. What's the U? 29. The V? Don't know. The A? The T is what we want. And the S? So S equals UT plus a half AT squared. So that's 4.905 T squared minus 29T minus 1 equals 0. Make it a quadratic.
Yeah, that's how it is.
Yeah, okay. Well, maybe I didn't say everybody screwed it up, but it surprised me the ways I was seeing it being done. So you have 2 answers. T is 5.95 seconds,
Minus 0.
and the other one is rejected because it's minus then. Well, I think you got the right answer, but you did it such a long way.
Yeah.
Such a long way. I know it took you 2 pages. Yeah, you tried it and then you scratched it out, or was that someone else? And then you tried
I
it
got the time to the maximum
on 1 page.
to the girl
Yeah.
in 1 page, and
Yeah.
then from the girl to the ground in
Second half.
yeah.
Yeah, it was interesting to read. I mean, it was right, but very long, very long. Okay, so again, no major problems there, right? It's okay?
Yeah.
Yeah. Okay, can I go on to number 3 now, which is another mechanics question. Okay, so we have 2 cars. The first car its mass is 1783 kilograms and it's moving with a speed of 13 meters per second and collides directly with another car of mass 1724 traveling at a speed of 19 in the opposite direction. 1724, know what I said, kilograms, and this way at 19 meters per second. So what type of problem is this? Yeah, collisions, conservation momentum. M1, yeah. M1, U1 plus M2, U2 equals M1, which this time, after the collision, they've combined together to form a new vehicle.
But it's minus.
And it's minus, thank you, yeah, and it's minus 19 here. So I'm using the M1 U1 plus M2 U2 equals, we'll just say M B, yeah. It's a bigger mass and a bigger, well, not necessarily a bigger velocity, but a combined problem. 1783 times 13 plus, no, minus 19 times 1724 divided by 1783 plus, no, that's a 1724. So I got a V of minus 2.73 meters per second. So they'll combine and start moving to the left. The reason it's negative is because this car will have more of an influence than this car. So when they crash, the crash will move leftwards. That's why it's negative. So I don't know if you remember getting a negative answer for this. No?
Yeah, I got the negative.
You got a negative here? Okay, let's.
If it's positive, what happens?
If you wrote down 2.73,
No, if it's positive.
you did positive, didn't you? I remember one person had the wrong sign, so it's the wrong answer. That was A3. Okay, A4. Oh yeah, okay, this one was interesting. People had a bit of trouble with A4, I remember. So can I scroll down? Are you writing this down, Adnan? You wrote the first one down. So the one you got right in the exam you wrote down, and the other ones, do you see what I'm getting at here? You wrote down A1, did you?
Yes.
And you got this one right in the exam, I remember.
Okay, the answer, not the second one.
Yeah. So the question you got right, that you didn't need to write down, you wrote it down.
Because I don't know how did I get it right. I'm supposed to get this right, not this.
Whatever. Okay. I don't remember, but I do remember you got one right.
Yeah.
Wait, is this recorded?
It's recorded, yeah. Yeah, but I would like you to write it down as go along. Something's wrong with my writing pad here. Alright, A4. A moon orbits a planet which is 359,000 kilometers. Yeah, so what do we have here? We have an Earth and a moon, and it's orbiting, so it's going around, okay? It'll take 28 days to do an orbit. And the distance here is 359,000 kilometers. And there is an acceleration. And we want to know what the acceleration is. Yeah? So this is using circular motion formulas. You have A, do you remember the formula for circular motion?
B squared over R.
Yeah, you have B squared over R as one formula. There is another one as well, but we'll go with B squared over R. Now, do we know the R?
Yeah.
Yes. Do we know the V? No. We don't know the V. Could we know the V? Well, we can use another formula for V. Does anyone remember the formula for V?
Omega.
Yeah, so this could be omega squared R squared over R, which is omega squared R. Do we know the R? Yes. Do we know the omega? No. Do we have a formula for omega?
So pi over C.
So this will equal 4 pi squared R over T squared. Do we know R? Yes. Do we know T? Yes. So it'll be 4 pi squared 359,000,000 all over 28 days times 24 hours times 3,600 seconds squared, and we have the answer. .42 times 10 to the minus 3 meters per second squared.
Nothing right.
I don't even remember what I did, but definitely not.
But it doesn't look so hard now, does it? No. And this is what I keep saying. I can make it look easy because the problem is not the maths is quite simple. The problem is knowing what formulas to use and when to use them. Not the maths. The maths is just put numbers in on a calculator, you know. It's not like you're doing differentiation or integration, anything like that. Okay, so I think, how many questions I give you in section 8? 12, wasn't it? So I broke it as 4 mechanics, 4 electricity, and 4 waves. So those are the 4 mechanics questions. Okay, so are we ready to have a look at the electricity ones now? Yeah. What's wrong?
When we have lessons.
The next physics class will start, I'm thinking the next physics class will talk about the lab report. I know. So I think we'll probably have 1 week on lab stuff, like the report, the calculations, all this stuff. Then after 1 week of classes on lab report, I'll give you 2 weeks to write the report. During those 2 weeks, we'll start something new in physics. I might even make one of the classes a time where you can work on your report and get help from me. We'll see. We're not under a lot of time pressure, you know, because once this report is done, then there's no other coursework, and we can kind of just worry about the exam. So I'm not pressed. The maths the physics I'm not worried about for the time. The maths we just have to be a little bit careful with because there's a lot to do in the maths. Okay, so A5. 2 resistors, closed circuit, parallel, a 2 and a 7 and a 7. So we have a 2 ohm, a 7 ohm, connected to 7 volts. Fair enough? And we want to know what the current is. So we could combine this into one resistor. 1 over R equals 1 over 2 plus 1 over 7. R will work out to be, as a decimal, 1.556 ohms. Or, what did you say? 14 over 9, yeah. Now we don't want the OR, we want the I. So we have our triangle VI-OR. So the I equals the V over OR, which will be 7 over this number. You know, I think actually most people, maybe even everybody got this one. Yeah, I think a lot of people got this, 4.5 amps. Okay, continue. A6. Okay, 2 capacitors are in parallel, a 5 and a 5. They're charged by a 5, 5 and 5, okay, don't know why I did that. How much energy is stored into combined capacitors, and they're parallel. So there's a capacitor here, and power supply here. 5 volts, 5 farads, 5 farads. We should combine the capacitors. Yeah. This one is in parallel, so it's actually the opposite formula. They combine to form a capacitor of 10. So that's a 5 and that's a 10. So the energy, I don't know if you remember, it's a half CV squared. So that'll be a half 10 5 squared, 125 joules.
I did this in the last second, the final part. I got the charge first, and I was like, no, that's energy stored with energy, and then I used the work. I got it in the very last second.
Oh, good. What did we say about the charge? When they're in series, they have to hold the same charge. And when they're in parallel, it's a different charge, isn't it?
What?
Yeah, when they're parallel, they can have different charges, but when they're in series, you have the same charge. No, it's just Ian was saying he thought I was looking for the charge, so
And
that would have.
they have a different charge.
No, the same charge. I think so. I think I said this in the lecture, and I think it's true that they have the same charge. It's in parallel they have different charge, and then with the voltage in series is different voltage, in parallel it's the same voltage, and then current in series it's the same, and in parallel it's different.
Homework you get the question diagram for the charge in each capacitor, and they was in parallel, and it was like a mortgage.
Were they the same or different?
No, one was.
Yeah, so that's what I'm saying. In parallel, they're different.
It was parallel and series.
Yeah, so the two parallels will be different, but together they must be the same as the one in series. Yeah. It's complicated. I know it's complicated. We'll continue now. This one was okay. Not too bad. Let's see, 7. Right. Yes, this one people did okay with as well. 3.22 millifarad capacitor is charged through a potential difference of 4 volts, and then it's allowed to discharge through a 2.76 kilo ohm resistor. So what you have is you have a capacitor and it's discharging through a resistor. The resistor could be whatever, a light bulb, it doesn't matter. And at the beginning the voltage is 4. So I'm asking you for the time until it's fully discharged. I think a lot of people remember that the time to discharge is 5 time constants, yeah. And how much is a time constant? You said it there. RC. So that's 5 times 2.76 times 1,000 times milli, which is 3.22 milli, which is 10 to the minus 3.
We don't need the volt.
You don't. It's called a.
Robin.
Not Red Robin. No, Red Heron. Red Heron, yeah. So I got. No, that feels wrong. I asked how long in minutes until the. Hey, I'm doing something silly here. I'm not getting. What answer do you remember? What answer you got? 5 times 2.76. I got 44 seconds, but my answer is supposed to be in minutes, so I was expecting a bigger number. I wonder. 3.22 milli kilo. See what answer I gave myself. This is why I remark in case I have the wrong answer. Yeah, because I said give the answer in minutes, I thought my answer should be more than 60. No, that's weird. Why did I do that? Alright, I guess I had a reason at the time when I thought it up. Okay, so I got here 44.4 seconds, but I asked for it in minutes for some reason.
So divide by 60.
Yeah. You know why I did that? I know why I did that. I remember now. The reason I did that was because I wanted to make the question have 5 marks, so I needed one extra step in it. That's why I did it. Because you notice that all the questions were 5 marks. Yeah. Okay, I think everybody did a good job on this one as well. Everyone, I think, or most people remembered the 5 time constants for this. Yeah? No? You were one of the people who forgot?
Yes.
Is it okay now? Is that yes or no?
Pat?
Sad, okay, sad, yes. 8. The last electricity one, then on to the wave ones. What's the story here? This one. I think the worst answered questions were 8 and 4 were the worst answered ones. People made a real mess of answering 8. Some people actually got it right, even though they made a mess of it, but nobody did it the way I was thinking you would do it. A crane lifts a mass of 1350 kilograms, a distance of 9.99 meters in a time of 17.3 seconds. What's the power?
MGH over
You didn't do that in the exam, did you? Are you sure?
Yeah.
Okay, you can say so. Power is work over time.
Oh, yeah, that's way faster.
Work over 17.3. Now what is the work?
Energy. Yeah.
It's the energy. Yeah, there's no energy here. And up the top there's potential energy. So the work done was given it potential energy. So that's mgh over 17.3, which will be 13. Now this is much easier than the way you were doing it. 9.81 times 9.99 all over 17.3. I'll give the answer in kilos. 7.65 kilowatts was the final answer. So a lot of people went with work as force by distance. They calculate force of the distance. Yeah, it was a disaster.
Yeah, that's what it is.
Yeah. But that's okay. Usually students forget that they can do this question this way. But now you've seen it, so now you know. Okay. Right, so this one's okay? So, okay. Was electricity, but more of a mechanics question nearly. Although, does power come up in mechanics, or do we only do it in electricity? No, I think we did it in mechanics, yeah. We did it in both, yeah. Okay. P equals IV, yeah. Okay, 9. A light wave travels from air to glass. The refractive index is 1.45 and it enters at 47. What's the angle of refraction? Okay, so air to glass. N1 is 1, N2 is 1.45. There's the normal. The light comes in at an angle of 47 to the normal. And then we want the angle here to the normal. So the rule is sine I over sine or equals N2 over N1. So that means sine or equals sine 47 over 1.45. Adnan, why aren't you writing this down?
I did.
Are you writing this down? Okay. So I get here sine or equals 0.0852. Now that's wrong. No, I'm still in radian modes from earlier today. Sine 47 divided by 1.45. So sine or is 0.504, etc., etc. So or would be sine inverse. So 30.3 degrees. The answer here. Oops. I think that's an okay question. It's okay. Did you get this one? Who knows? I'll know when I go back to the office. I'll look. Okay. Ready to go on to number 10? 3 more waves questions left. Number 10. A stationary sound wave is produced in a closed at one end pipe. So it's closed at one end. The frequency used to produce the stationary is 103 and the pipe is 81. Huh?
The lambda is equal.
Yeah, what I didn't say here, I should have said it though, is it's a fundamental wave, but I think that's what everybody did anyway, because otherwise, what are you going to do? So we'll draw the wave in here, closed at one end, so it's a node here, and an antinode here. And this length is 0.81. So, what's the wavelength? How many of these? 4 of them. Can you see that? This is only a quarter of a wave. It's 4 of them. So that's 3.24 lambda. The frequency, I gave it to you as 103 hertz. And the formula for the V is what I want. V equals lambda f. So it's just a matter of taking 3.24 and multiplying it by 103, and you get.
Homework, Stephen, you got the question asked for close at one end, and you saw lambda is equal to 8, not 4.
Maybe there's a mistake in my homework then. Closed at one end and open at the other end, or open at both ends?
He said it's closed at one end.
In my homework?
Yeah,
like this one?
Yeah.
The other difference though,
Is it a fundamental?
yeah, because you can have different waves inside of it. So this is the first wave that fits inside of it. But in the homework, if I said 2, then I must have been drawing something like.
He said it's the 3 wave, the frequency is equal, the lambda is equal something, and the 6 wave 5
Yeah.
fundamental equal, lambda equal something.
It was 2 equations.
Yeah.
That's a different type of problem. That's much more difficult than this one, because that's the one where you wanted to calculate. You had 2 equations. Yeah, no, I know this one in the homework. There was the 3rd one and the 5th one. Yes.
But it's the same like.
No, it's same idea, but much more difficult because the information was more complicated. Here it's more straightforward. I give you fundamental wave, I give you the frequency, I give you the length. So I really was looking for you to use this formula and to understand that it was 4 times the length. Okay, meters per second. Is that okay? Yeah. But I think people got this one. Did you get this one? Did you use 2?
I don't remember.
Did you draw it? Did you draw?
No.
Always draw a picture in physics. Very important. Very important. I think it was Einstein that said once you have a good picture, then the problem's nearly solved. So pictures. I don't draw my pictures because I like drawing pictures. I find them helpful. This is why. Okay. 11. A boy sits in a boat that's bobbing up and down. The boat rises 10 times in a minute. and the waves are 1.63 meters long. So here the boy is sitting in the boat and the waves are coming along, and you're told that he bobs up and down 10 times in a minute. So that means 10 times in 60 seconds. So how long for one
5:30.
bob? Yeah. So that's 1 in 6 seconds. Divide by 10.
By 10.
Yeah, because I'm getting the time it takes them to do one oscillation. If he does 10 in a minute, then that means he does 1 in 6 seconds. So what I've just worked out is the t equals 6. We also know the wavelength. I give that to you in the question as 1.63. And I would like the v. So v equals lambda f. Does anyone remember the formula for f? 1 over t. So the answer is 1.63 over 6. And again, I think a few people got this one, so that's kind of good. 0.272 meters per second. Yeah? Yeah? Good. Last one for section A, 12. A girl walks between two speakers. She notices that the music gets louder and quieter. She walks at 2 meters per second and she hears the peak every 0.7 of a second. What's the frequency? So what happens here is this your friend? Hisham! Still causing me trouble. Right. So the waves come out from the speakers, and as you know, what does it make here on the wall? What's it called? Do you remember the name of what's on the wall?
Pattern.
Yeah, what pattern?
Dot.
A dot pattern? No. Interference pattern. So there'll be a bright one here, that's n equals 0, and then you have like 1, 2, 3, and here is like 1, 2, 3.
Yeah.
Fair enough? What do we know? She's walking along here at 2 meters per second, and she hears the peak every 0.7 seconds. So how far in between the peaks?
2 multiplied by 0.7.
Well, using our distance, speed, time triangle, distance divided by time. Sorry, speed multiplied by time. So yeah, 2 multiplied by 0.7, so that is 1.4 meters. So every gap here is 1.4 meters apart. Okay. We have a couple of formulas. The first one is n lambda equals d sine theta, but this isn't really the one to use here because we're not looking at angles. So there's another formula which I always forget, and let me see, I need to learn how to remember this. Lambda equals, and there's a big D and there's a small d and there's an x. Big D. This is the formula?
I think the S in the position of the lambda.
I have it on the wrong side, yes, thank you. It's x equals lambda d over d. That's it, isn't it? Yeah. We know the x, true? We know the lambda, no. Do we know that these? No. We don't know this, do we? We don't know this. Why not?
I think you multiply the distance, the girl is working at 2, multiply 0.7, and it's from A to B, so you multiply by 2, because it's from north to north. is how you got the lambda, and yeah.
It's almost like I didn't. Oh, I'm sorry. I'm looking for the frequency, but I give you the V, the speed of the sound. So we also know the V is 330 meters per second, and that's key because we have to formula V equals lambda f. So I could use this formula together with this formula. Now, which way around? I'm looking for the f, and I know the V. So what I'm thinking is, if here I say lambda equals V over f and put that in here, then I'll get x equals V over f d over d. Now let's see, do we have enough? Do I know the x? Yeah, it's 1.4. Do I know the v? I do. I want the f. Now let's look at the d's.
We know one of them is 1.4.
Which one?
We know the x. That's one.
We know the x is 1.4.
Can you show us the question?
No, I was wondering if I didn't give you all the information. A girl walks between two Oh, I misdrew the picture. This is the problem, because I read it too fast, because I was being careless. I was thinking a girl walks down a hall. She walks between two speakers. This is totally different. So what's happening here is there's the speaker here and the speaker here, and she's walking between the two speakers. So there'll be a wave between the speakers, and we'll have the nodes here, and it's still the same number. What's the distance between the nodes? 1.4, etc. We also know the V is 330. And what else do we know? That's it.
Yeah, and you
Yeah.
from node to node.
Yeah, that's it. That's what you were saying earlier. I get it now. So from node to node, that's half a wave?
Yeah.
That's
So
half a wave,
multiply
yeah.
1.4.
So we know that the wavelength is 2.8 meters, because from node to a node, that's half a wave. And we have this and we have this, so we have V equals lambda f, f equals V over lambda. 118 hertz. Let me just check my answer. Make sure I got the right answer when I did it. Yes. Okay. Okay. Good. Right. So yeah, that last one. English. Everybody has trouble with English, you see. Even me. Okay. So that's section A. So we'll have a look at section B now. Okay. Yeah. We look at section B. Everybody did 1 and 2 except for Musharif, who did 2 and 3. Just to be different. Yeah.
No. But I didn't finish the closest time graph.
You don't like it?
No, I don't like it, but I think draw the graph is much harder.
Yes. Some people drew me ugly graphs. Who was it? Somebody drew me a very ugly graph.
Could be me.
Could be me.
Was your graph like about this big?
No.
On the graph paper? You put a box around it? You put a box around it?
In the middle to the right,
Yeah.
there was 2 other.
There was stuff around it.
Yeah.
That was ugly.
Was it correct,
In a way.
in a way?
It had the right shape, but it was... I needed medicine after I looked at it. It was ugly. Now, it wasn't the ugliest graph I've ever seen, but it was still pretty ugly. Okay, let's have a look at section B now. State Newton's tree laws. Okay, Swan, go ahead. Give me the tree laws. Practice your English.
Hi.
1, 2, 3. What's the first law?
First law. Wait.
Do you know it? Don't. Okay. We'll see. Do you know the first law? Yeah, you got these.
I didn't know the second one, but first one.
Wait, what?
Every day
What?
meal.
Oh,
Everyone.
the second one, I just don't know the one. So I think I wrote the wrong thing.
Okay. What's the first one? Do you know?
Wait, I need to have to remember.
Oh, come on. You either know it or you don't.
I used to know.
Do you know it?
I don't know how I wrote it, but like a stationary object remains stationary and accelerate in one way.
Oh, yeah, you wrote like that.
Yeah.
Not quite on the money for that.
Unless
Unless the force. I lost my word.
You did, yeah. It started off okay. What we'll say is an object at rest or moving at constant velocity, yeah, will stay at rest or moving at constant velocity unless acted, yeah, or whatever grammar you want to use, unless acted upon by an external force. Now, I realise that English might be a bit old, so you probably would have said it another way, like you would have said, it will stay at rest or unless a force is applied. I don't know what words you're more comfortable with.
Wait,
Yeah?
can I see the question?
Yeah.
It's only at the third law.
No! Oh, you thought it said St. Newton's third law. No, it's St. Newton's tree laws.
What does that mean?
1, 2, 3.
There's a difference.
I thought only say the third law.
No, because I would have said St. Newton's third law. I said St. Newton's tree laws.
It's same.
It's not saying sorry.
Damage.
Damage?
Damage.
Damage 4 marks. It was two each. 2, 2, 2. I know, it's painful, I know. $49.4. Don't worry, you won't make that mistake again. Oh no, don't worry about it. Don't worry about it. Huh?
What's life?
He's certainly not worried about it.
Well, I did this one, right?
Yeah.
Hopefully.
We'll continue. Oh, it's okay. Do you need to go to the bathroom? Are you sure? You need to be a bit more like Adnan. Relax a bit. They're not too much like Adnan, just a little bit. Alright, that's the first one. Adnan, you're going to be like the spokesperson for relaxation for the class. No, never mind. Here. No, never mind. Mir, what's the second law? You said you remember it now. No.
Wait, does the order make a difference? If you wrote it like, for you, does it make a difference?
I wrote that.
I think somebody had something. Somebody gave me Kirchhoff's laws, but backwards. I think that was you. So I took a mark off if the order's wrong.
I don't know, maybe that's me.
How?
I asked what is Kirchhoff's loop. Somebody said Kirchhoff's loop law is the current going in equals the current coming out, and then someone said
Oh.
his junction law means the voltage around a
You
loop.
take the two laws.
Yeah, but this person wrote down quite clearly
The junction.
loop law,
He made the
and that gave me the junction law, and then they wrote down junction law and gave me the loop law. Was that you?
No.
Are you sure?
Definitely not me. Definitely.
It was somebody. I could have sworn it was you. It doesn't matter. To answer your question, that they lost the mark for having the order wrong.
But in this, like,
Yes,
no, sorry, in Newton's 3 laws.
yeah, the order does matter.
Okay, yeah.
Second law, who wants to give it to me?
Force is the product of mass and acceleration. Is it?
Yep, I would have just accepted that.
Yeah, I did that too.
LED.
No. Now what's the last one? Now what's the last one?
Yeah,
go
Everyone
on.
got number 3 right, I think.
Every action has an equal but opposite reaction.
We're gonna get a big on fighting.
What type of grade?
Some of us should be less excited about that than others. Okay, on to the next part of this question. Yep. The graph. A 10 kilogram mass starts at 2 meters per second. Got some interesting graphs here. So for the graph, I wanted you to use graph paper. I wanted the labels. I wanted the units. What did I say it starts off? 2. So that's a 2. Accelerates with acceleration of 9 for 8 seconds. So that's an 8. It then continues at a constant velocity for 6 seconds. So here is a 14. And then decelerates with 8 to rest. And the acceleration here at the beginning is 9 meters per second squared, and at the end this is a minus 8 meters per second squared. And my question is, calculate the distance travelled. So we've got triangle, we've got this thing, we've got this thing, and we've got this thing. Now, a couple of problems. We do not know the height here, so my first piece of business is to work out this height. Now, the acceleration is 9. Rise over run, yeah. So, if this is 8, and the slope is 9, then this one here must be 72, because 72 over 8 is 9.
I got this.
That seems ginormous. Anyway, 72. So here is 72. Okay. Also, we don't have the time here, do we? So again, what's the height here? 74.
Okay.
Because 72 was here to here. Oh, so actually I shouldn't have written 72 there. I should have written 74 there, because this is 72. So that's 74. This we don't know, but we know that this over this should equal 8. So that has to be, works out a bit messy, but that's 9.25 seconds, because 74 over 9.25 makes the 8. Now we can calculate the distance travelled, which is the area. 2 times 8 plus a half, 8 times 72. plus 6 times 74 plus a half times 9.25 times 74. So this one here in blue is this guy. This one here in green is this one. This one here in black is this one. And this one here in red is this one. And the answer is
Why did you put half?
triangle.
What about the first? Yes.
Question withdrawn. Ooh, I got a big number. 1090. Of course not. Yeah, 1090. Oh yeah, the last part everybody got it. What was the force? So F equals ma.
So what is A?
F equals ma.
Yeah, that's easy because it says to put it to rest. In the question. Yeah, that's easy. I think I did.
You did. I think everybody got this.
Oh, you didn't do this.
He didn't do this, and now he's thinking, oh, maybe I should have done it. Aren't you? Be honest. No, that's what you're thinking. You're looking at this going, maybe if I did this, I would have gotten that one extra mark.
I would use Pythagoras in the first, and I would lose.
It's really the distance.
How can I find 72?
72, yeah. Do you remember the vocabulary? This is rise, run, and this is the slope. The slope you know from maths. So the slope equals rise over run. So you know this and you know this.
But this is a right angle. The
Yeah,
slope should
but
equal the...
No, this is not Pythagoras because I'm not saying the length is 9. I'm saying the slope is 9, not the length.
Is there a difference?
Oh yes.
Why? This is a slope and also...
This is 8 meters and this is 72 meters, but this is 9 meters per second squared. It's not even the same unit.
Yeah, it's not. It would have to be. Yeah, okay. We'll go on to number 2, which everybody did. Yeah.
Is that all the question?
Yes.
Only one?
Yeah.
Now you're thinking, guys.
Right, B2. Kirchhoff's 2 circuit laws. So, Musharif, what's the loop law?
That the electric sum of the voltage of any closed network is 0.
Okay, yep, that'll do. Or the formula, the sum of the voltage over any loop is 0.
I don't have to write the...
I would have been generous. I would have accepted this.
Really?
Yeah.
Okay. And the junction rule is sigma I down junction equal to this.
That's correct.
Yeah. That's it.
For me, that's enough. Okay, so that's the first part. Now, the next part people had a lot of trouble with. Some people got half of it right. So, the junction law and the loop law, they're examples of conservation. In this case, a lot of people said conservation of current, which isn't really right. I know it stinks a bit, but it's conservation of charge. That the charge that goes in must equal the charge that comes out. It's a conservation of charge.
So if I wrote current is wrong? Really?
Okay.
And this one, the loop, I think everybody, or nearly everybody, got the loop one. So when you look at a loop and you say that the voltage equals 0, like the E here, the R1, the R2, and the R3, and you say the voltage here minus this, and this equals 0, that's a conservation of energy. In other words, it's like saying the energy provided here is equal to the energy used here. Do you get what I'm saying? You know conservation of energy, don't you?
Yeah.
So the energy that's given here is used here. So this is a conservation of energy and this is of charge. Now, I don't think anybody got both of those right, so make sure you make note of that.
I didn't understand even what is conservation.
I figured that.
Yeah, right.
Good, good. Continue.
Yeah.
Did you all enjoy doing part C?
No.
No.
No one.
No?
No. Good.
Yeah, it was messy. I don't think anybody...
Got it.
No.
Okay.
But the good thing is, I think most people have the right equations. So you all wrote down the right equations. So we'll go with the junction rule first. So what can I say here? I1 minus I2 minus I3 equals 0. So I1 minus I2 minus I3 equals 0. Somebody, maybe it was you, Iyad, said I1 equals I2 plus I3. Was that you?
I said I2 minus I3 minus I1 equals 0.
Say again?
Now, can you go back, please?
Yeah.
And see what I did? I did I1, I3 equals I2.
Yeah.
Me too.
No. Ah.
I1, I3.
Yeah.
I1 plus I3 equals I2.
No, because I1 is going in, 2 and 3 are coming out.
I1 equals I2 plus
Yeah,
Yeah.
that's right. I also mean I3 minus.
You made the same mistake?
Yeah,
This is why you didn't get to the answer in the end.
yeah.
Unfortunately, you had the wrong sign on the... You said I1 equals I2 plus I3. So the sign was wrong on I3. Yeah. Okay. What loop will we take? Will we take E1? So what's
But
E1?
it's like,
It doesn't matter which loops you take. What?
no. You said form three equation of I1 and I2 and I3.
Yeah.
I said 4. 3 with
But did you use the wrong one?
How?
Did you use the wrong equation to try and get the answer?
the equation of the I and R will be also wrong?
No. My question is, when you tried to get the answer, did you use the wrong equation to get the answer?
No, I used only the 3 equations.
You didn't use the I1
Yeah,
equals
yeah.
I2 plus I3.
Yeah.
And you gave me 4 equations.
And you could give me 3 equations.
Okay. Then that's okay. But you didn't get the right answer anyways.
Yeah, why?
What do you mean, right? I'm going to get the answer now and it's not going to be the same as your answer.
In the end.
In the end.
The final.
Final answer.
Okay.
You don't have to believe me, you just have to watch. Okay, E1. E1 is 2. So we have 2, and we go around minus I1 or. That's this one. Around minus I2 or 2. I2 185. And then what other one will I take? Will we go this way, I think? Yeah, no, I'll go this way around. This will be interesting. So E1 is 2. Now what happens here? Plus 4. What happens here? Plus, because... backwards. Yeah, current's going backwards. plus I3, 311. Minus I2, 185. Yeah, so let me just rewrite these. I1 minus I2 minus I3 equals 0. 97 I1 minus 185 I2 equals 2. No, plus, I took these two to the right. 185 I2 plus 311 I3 equals, get my signs right. 185 I2 minus 311 I3 equals 6. Okay.
You know, Stephen, I reduced another one. Another equation.
Yeah, that's fine. There's many because you could have taken the outside loop as well.
So I got the 6 marks
But
for the...
I am a lazy man, and I'm going to pick the ones I know will be quickest.
No, for me.
For you.
For what I wrote in the exam.
Yeah.
Do I get the 6 marks?
As long as what you're doing is right.
Yeah.
But your answer should match my answer. In
I
the
got
end.
4. 3 is right.
You got 4 answers.
Yeah.
But there's
and
only
one-
3 unknowns. I1,
Oh,
I2, I3.
4 equations.
Yeah.
I mean.
And 3 unknowns. So you have to use 3 equations.
The first question says by using Kirchhoff's two-circuit law for 3 equations.
Yes.
I found 4 equations.
Yeah.
But 3 of them are right. But the I1 minus I2 is wrong.
Yeah. So I'll give
How
you.
much marker do I use?
Yeah. So it was 6 marks. Okay. So I believe, if I remember, you know what? I'll just check it right here. So you get 2 marks for each equation. If the 3 equations are correct, 6 marks.
Yeah, but I do 6 marks, 3 equations, right? And
You
another one.
have 4
Yeah, so I'll pick the 3 that are right.
So I will get the mark.
You should. Yeah, if I like you. Right, so part C was to make the equations, which I've done. So that's part C. And then the part D is to solve. So, what's the best way to solve this now?
Move 5-2.
Huh?
Move 5-2.
Yes, I think it might be a different mode for a triple. Mode 5. Oh no, you're right, 5-2 is the one. Yep. So what do we do here?
You solve I1 minus
No, yeah, but how?
Yeah. You solve I1 minus I2 minus I3 equals 0 with the second equation.
Let me show you. Look, I'll multiply this by minus 185. So now I have minus 185 I1 plus 185 I2 plus 185 I3 equals 0. 97 I1 plus 185 I2 equals 2. 185 I2 minus 311 I3 equals 6. So what I'll do is this one minus this one, and this one minus this one. So if I zoom out a little bit, minus 185 minus 97,
97.
is it really? No, it's not. Minus 282. Minus 282 I1. These cancel. Plus 185 I3 equals 0. And then here, 97 I1 cancel. Plus 311 I3 equals minus 6. This is okay, isn't it? You've done these in maths class. So, what should I do now? Multiply this one. You know what? I'll make the numbers smaller. I'll divide this one by 282 and divide this one by 97. So I'll get minus I1 plus 0.656 I3 equals 0. I1 plus 3.206 I3 equals minus 0.0619. Now what do I do? Yeah, how? I just finish by adding
Add
them.
them together. Yeah.
So I get 3.862 I3 equals minus 0.0619. So I get I3 equals minus 0.016 amps. So that's the I3. How can I get I'll get I1 next, because I can take that and just put it in here. So then I get I1 equals minus 0.0619 minus 3.206 times I3, which is minus 0.016. So my I1 works out to be minus 0.011 amps roughly. And finally I get I2. I probably should use this equation. I2 is I1 minus I3. So I1 minus I3. So now I have I2 equals 0.005 amps. Oh my goodness, let's see if that's right. Now before I check my marking scheme, I'll use mode 52, see what I get. Minus 1, no. 1, minus 1, minus 1, 0. Is it mode 52? Yeah, mode 52. 1, minus 1, minus 1, 0. 97, 185, 0, 2. 0, 185, minus 311, 6. Right, what did I say for I1? I1 minus 0.001, okay. I2, 0.01, no, off a bit. And I3 minus 0.013. I made some mistake.
I think there is a mistake in the I3 equation.
Do you think so? The I3 equation? The last one?
The third equation I am saying I3.
Which
The third
one?
equation.
Where?
185 I2 minus 311.
You think this is wrong? And you're telling me this now? At the end? Let's see my marking scheme. What answers did I get? These look like the answers I got.
0.016.
I1 is minus 0.001. Minus 0, oh no, it's not right. Are these the answers on the calculator? Okay. Good news. The answers here when I did them the night I did them were right. The answers when I just did them now are wrong. So these are the right answers, but I made some mistake somewhere here. It doesn't match up with the right answer. And also I can confirm on the calculator that these are the right answers here. But some number mistake happened.
It's minus 6. There was 6 and now it becomes minus 6.
Sorry. Yes, how did that become... Oh no, because it's the second minus the third. So it is minus 6. Plus. But it's 2 minus 6, which is minus 4. That's the problem. That's the mistake. So it's 4 divided by 97. So that should have been minus 0.0412 So that here is wrong, which means this is wrong. Well, at least it was near the end that I made the mistake. 0.012. Yeah, so that fixes the mistake. What's up?
Said at least we get marked.
Oh yeah. So like if this was me doing the exam, this is how many marks I would have gotten. I would have gotten 1 mark for getting rid of one of the variables, 1 mark for getting rid of another variable, and then 1 mark for making it a degree 2 system. So in other words, it was 3 marks to get to here. Then the last 3 marks were for the right answers at the end. Now because this one was wrong, it meant these 2 were wrong as well. So for me, if I was doing this as a student, I would have gotten 1, 2, 3, and then lost these 3. So I would have gotten 3 out of 6. And these ones I would have gotten 6 out of 6. So, you know, it's, what's that now? 9 out of 12 is still okay. It is. It's an A. I know, but when I'm doing this, in the exam, I wouldn't be looking at you, and I can concentrate more. Because your brilliance distracts me. Yeah, just like that. Right. So the last part here is which way are the electrons flowing in R3? So the current is negative. So what does that mean if the current's negative? The current's backward. So the current is not going this way, but it's going to the right. The current goes to the right. Which way do the electrons move? Left. To the left. So the answer is to the left. Yeah. Yeah, or just to the left if you want to say.
I said opposite the electrons. Is that
To the voltage.
Opposite of the what?
To the voltage 4, I think.
No, that doesn't pin down.
I did, okay. What did I say?
I think somebody said opposite the battery or towards the battery or
Yeah, I
something.
mean,
You said which?
to the
battery?
A2, yeah.
Then that's okay. You could have said to the left, to the battery, clockwise. Yeah. So, left is the final answer here. Yeah? Okay, can we do the wave one and finish then? Right, a standing wave. Draw it in the first harmonic. Label the nodes and antinodes. Is it closed at one end and closed at the other? Right. First harmonic, so it looks like this. Here, this is the antinode. This here, the node. This is the length of the pipe, and this would be 1/4 of a wave. So I've just done part A and part B. Now on to part C. 322 lines per millimeter. 322 lines per millimeter. So that means 1 over. Oh, hang on. What did I want? The distance between the lines. Yeah. So 1 millimeter divided by 322. .11 micrometers is the answer here. Okay, see? Or 10 to the minus 6 if you want.
I got it 1 over 322.
Yeah.
Multiply 10 to minus 3.
That is correct.
That's correct.
That is correct. Light is incident normally on a diffraction gradient. Determine that the second angle, the light has a wavelength of 337 nanometers. So what happens is the light comes into the diffraction gradient 637 nanometers. Do you remember this? And then it produces the pattern here. So we would like to know the angle for the second order. N lambda equals d sine theta. Sine theta is n lambda over d. 2 times 637 times 10 to the minus 9 divided by 3.11 times 10 to the minus 6. So this works out to be 0.4096. So that makes theta equal to 24.2 degrees. That's part D.
Even I
Yes.
draw there's an harmonic wrong, but I labeled the rectangle.
Then you get that mark and not the other mark. E. What colour is the light? 637 nanometers. What colour is that? It is a...
Orange.
hang on, let me think. It has a big wavelength, small frequency, low energy, red orange kind of colour.
Between red and yellow, so it's orange.
Okay, orange, fine. Orange, although if you said red or reddish, that's fine also. As long as you didn't say like blue or green or something. Okay, and then F. What is the maximum order? So the maximum order, theta must be smaller than or equal to 90. So that means sine theta must be smaller than or equal to 1. So that means n lambda must be smaller than or equal to d, because this is at most 1. So n must be smaller than or equal to d over lambda, and d over lambda, what did I say the d was? What was the d?
3.011.
3.11 micro. And what was the lambda? 637 nano. 4.88. So what's the maximum n? That's how it's done. So, Mayor, you can see you have plenty of time, because I did the whole exam.
Yeah.
About 90 minutes.
Explaining and reading.
And looking at you as well. Oh.
That's gonna help you.
No, that's true. So, like, that's what I mean.
Yeah.
That gives me a plus.
It
It cancels, yeah. So, when's our next physics class? I think we might start looking at lab tomorrow?
Friday.
No, impossible. We've only had one physics
Thursday.
class. Thursday, that makes more sense. Not that it really matters. Is there any day we have maths and physics together, so we have 4 hours?
Like today?
No, but together.
Oh,
Like,
no.
oh, good. You don't really want to be sitting in front of me for 4 hours.
In front of you.
No, it's you who don't want to be there and talking about
Thursday, we'll talk a little bit about your lab report, but before we start the lab report, I have to do a little bit of a lesson on what's in the report, the format, and also talk a little bit about something you're doing with Lorraine, the uncertainty, the error. Yeah. Now I'm going to use the same formula she's going to use, so it's good to see it twice. Are you finished that with her, or you're doing it? Oh, you haven't done it? She said she'll do it.
Yeah.
Yeah, okay. Did she say when? Tomorrow.
5 o'clock.
5 o'clock?
Yeah. Is it possible?
What are you doing at 5 o'clock?
I don't know, I mean, we don't have meetings with her.
Yeah, but he said he sent an email yesterday.
Yeah, all of it, maybe she just means for students, I don't know, maybe it's the same as sometimes she means with everyone, but she means what they do. I'm not sure.
No matter, that's easier for me because you would have seen it before Thursday. But I might be a tiny bit more technical, which is fine. So that might be Thursday or Friday. So you could probably start the assignment on the weekend or next week, and then you have 2 weeks to do it. Yeah. Okay. Do you want another exam anytime soon?
Or,
For fun.
no, I mean, semester 1?
Semester 1, yeah.
Why not?
Or do you want to, you see, what I would really like people to be doing in physics as well as maths is to be looking at exam papers online, be trying questions at home. So if you're looking at this thinking, oh, I found blank hard, then you should go, open the papers and find more questions and try them.
Even
Yeah.
the lambda is 637 nanometers.
Yeah,
So it's 337 to the power 10 to minus 9.
yes.
So how the maximum order is just 4.
Because the D is also very small,
The D is 3.11.
10 to the minus 6.
It's not. We found it up.
It's micro, I think, or something.
D
Is it
D
micro?
was 10 to the D was 10 to the minus 10 to the minus 9.
Why?
What do you mean why? There.
One million.
Trust me. The number you said, 1/322 times 10 to the minus 3, that's the same as 311 micro. Check it if you don't believe me.
The 10 to power 3 go up and become 1000 over 322. Yeah?
What? Watch.
It is 1 over 322.
Yeah, or 10 to the 3 or 10 to the minus 3 over 322.
But the sign will be positive because it's going up. Like when you...
This minus? No, it's already on the top. Because millimeters on the top. It's not moving, it's already on the top.
Okay. Yeah.
I haven't said we're finished yet. Right, so if you want, we'll try and get the lab stuff done. We could try and even start it this weekend or next week. Next week, you probably want to bring your laptop to physics. Okay, so next week you definitely need your laptop in physics because I can help you and there's some calculations I want to show you how to do, and I want to show you how to do some graphs as well that you need in your report. So it'll just be easier if you have your laptop. You don't have ICT anymore, or do you, on Friday?
Friday, yeah.
With who? Is it somebody? Oh no, I don't have to worry. I definitely know that.
Some named Jamie.
I don't know what his Excel is like. Oh well.